Advanced operators. Actually, it's kind of a miscellaneous, all the operators I haven't already shown you nugget. It's kind of a list. We'll cover the is and as operators, the contains and in operator. We'll look at replace, split, and join. These two kind of go together. This one I'm sticking in there because you kind of have seen that before, and I'll just quickly review it. We'll look at some of the more advanced math and assignment operators. The bitwise operators, that's going to take a minute to explain. A couple extra Boolean operators, some redirection operators. Now, all right, legally this is an operator, but it's a technique called dot sourcing. I'm going to show you that too. Very useful. That'll take some explaining too. The range operator, the formatting operator, and some of the operators you use to work with arrays. So we have quite an agenda ahead of us. Let's get started. Okay, let's start with the is operator. I'm going to take just a simple variable here. Let's take x, and I'm going to put a string value in here. The is operator is designed to tell me if this is of a particular data type, and your data type goes in square brackets. So that is a string. X is int. No. Pretty straightforward. The as operator, which you've actually seen in a couple of previous nuggets, is designed to return a version of a piece of data in a different form. So x as integer. Now that returns nothing, and that's because hello doesn't make sense as an integer. There's no way to make it into a number. Another way you could see this is if I give it a non-integer number and ask it for the integer version, you'll notice that even rounded it up to 57 because it was 56.5. So here's what else I can do. I can take a string that has digits in it. Now this should show up as a string, and this I can cast as an integer. And what that's doing now is it's returning an integer version of it. So what you would often do is capture that into another variable. Y now contains, and you can tell me if this is an integer now, and it is. If you need to reverse the logic a little bit, y is not string. True, y is not string. It's something else. So you can play around with the logic however you want to on those. So that's is and as. Next is contains. Now you've already met the like operator. You should have seen that in the previous nugget. And like works something like, do I still have a string in there? Oh, let's put a string in here. So x contains PowerShell. Like is your wildcard operator, if you remember. Right? Some folks will actually mix that up with contains, as I mentioned. They'll do x contains shell. And you get a false out of that because what they're thinking is, I want to see if x contains the word shell, and I get how that reads perfectly well on the screen. It's just not what the contains operator actually does. Let's do this. I'm going to create an array. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oops, 6. So x now contains those 12 elements. Contains is designed to tell me if an element exists in that array. X contains 2. Yes, it does. Does it contain the string 7? No, it does not. So it's designed to take one element and tell me if that element exists in this larger array. There's also a not contains if you want to torture the logic a little bit. True, x not contains 7. That'll make your old high school English teacher's head spin right off her shoulders, all the double negatives. So that's what the contains operator does. Now, in Windows 8, we have a slightly new version of that. So I have to start over here. X is, tell me if 7 is in X. True. Tell me if 8 is in X. False. All this does is reverse the logic. Instead of putting the collection on this side and the single item that you're checking on that, you put the single item on this side and the collection on this. So this is in version 3 and later. It's exactly the same as contains. There's also a not in. It's just reversing the order that you use these operators. Now, the next one, the replace operator, you've already seen a little bit in previous nuggets. Let's take a simple variable. We'll put a simple string into it. And I want to replace all instances of L with X. And that produces a new version of the string where the L's have been replaced with X's, but it does not affect the original string in the original variable. So that's the replace operator. And in the nugget on regular expressions, you saw how that can also be used with regexes to do that replace operation. Now let's look at split and join. I'm going to create another simple array here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now PowerShell by default displays each array element on a line by itself, and I can also use an index to access individual elements within the array. Here's a fun little math operator. I'm going to show you, this is the same as something else. I'm going to add some stuff to this. We'll add some strings. Check to make sure those are in there. So that plus equals is the same as saying take ARR and set it equal to whatever's in ARR already plus so it's just a shorter way of expressing that same thing. I'll show you some other variations of that in just a moment. Let's make sure ARR has everything in there. So good, we've got a whole bunch of elements. Let's take ARR, create a joined string that makes these a single contiguous comma-separated list. So what that does is it takes each element and it sticks a comma in between them all. So I can save that now. We'll just call this list. And that's just a simple basic string. Neat thing about strings. You can still use an index number to get to the individual characters. But it's not quite the same as accessing elements in an array because the second character is a comma. There's no way for me to use this to pull out an entire multi-character element like 4 or 6. I can only grab single characters at a time. So what if I had a list like this and I wanted to break it down into its constituent elements? Oh, I'm already using ARR. Let's just use A. A equals list split on the comma. Now what's in A? I got my original array back, and now I can go grab the last item, which is the entire SIX element. So join takes an array and creates a separated string out of it. Split takes a delimited string and breaks it down into an array where each element is a separate item in the array. Now, you've already seen right there how I can use commas to create an array. Here's another trick a lot of folks don't know about. That creates an array also and puts just one item into it. So doing a comma first says this is definitely an array, but I'm only going to put one item into it. Now some of those math operators. Let's put 10 into x. X plus equals 10 makes for 20. So we've added 10 back into x. X times equal 10 should make that 200, right? Yep. So you've got that for division equal and minus equal as well. On a string, s plus equals, we'll take another string, so it concatenates. And again, all of this is just a shortcut for taking a variable, setting it equal to whatever's already in that variable, plus something else. So it's just a shorter way of doing that. Both of those are completely valid. You'll see people use them both. There's also some unary operators. What's in x now? 200. X plus plus adds 1, and x minus minus subtracts 1. So if you're in a loop and you just need to count something and you're just counting one at a time, instead of doing x equals x plus 1, or instead of doing x plus equals 1, people will do x plus plus. And incidentally, that's where the C++ language got its name. It's C plus 1, or C++. So interesting little bit of trivia there. So replace, split, join, some of the unary operators, and some of the shortcut math operators. All right, next we're going to talk about the bitwise operators. These are a little tricky. These require that you be able to do a little bit of binary math. So I'm going to draw out a little series of columns here. We've got 1, 2, 4, 8, 16, 32, 64, and 128. Those columns represent the values assigned to each digit in a byte, so each bit in a byte. For example, if I were to put a 1, 1, 1, 0, 0, 0, 0, 0, that's a complete byte. So I'm going to draw a line here just so we remember that this top row is columns. I'm going to add the values. 1 plus 2 is 3, plus 4 is 7, right? 4, 5, 6, 7, yeah. So this equals 7. Now let's take another one. I'll do 0, 1, 0, 1, 0, 0, 0, 0. Add them up. 8 and 2 is 10. So when a computer stores the number 10, it actually stores it in this fashion. You'll notice if you add all of these up, their maximum value is 255. Their minimum value, with everything set to 0, is 0. These bitwise operators are designed to look at individual bits. So if I were to say 7 band 10, so binary and, or bitwise and, 7 band 10, it's going to look at the individual bits. The only time I'm going to get a 1 in the result is if there's a 1 in both inputs. So 1 and 0, nope, that's not two 1s. 1 and 1, that's a 1. 1 and 0, that's a 0, that's 0. 0 and 1, 0, 0, 0, 0, 0. So the result of this is 2. So it really requires that you kind of be able to break these things down to understand them. Now, when would you actually use this? Typically, you'll run into technologies that use these as bitwise flags. So what you'll see is, you know what, Active Directory will do this. Deep inside Active Directory, there are some bitwise flags. You know, the first one might be, is the account enabled? The second one might be, is it locked out? The third bit might mean something else. So each of these bits has a business level meaning. And the way you tell if an individual bit is turned on or off is to use an operator like band. So let's take a look at what that looks like. 7 band 10 is 2, like I said. So let's walk through a couple of other instances here. 7 bore 10 is 15. How in the world did it come up with 15? Well, again, you've got to break it down. So let's draw our little columns here again. 1, 2, 4, 8, 16, 32, 64, 128. Each of those is just a power of 2. For 7, we said it was 4, 5, 6, 7. The other one was 10, which was 8 and 2. Now the bore operator, binary OR, is going to return a 1 if either or both of the two bits is a 1. So the result is going to be 1, 1, 1, 1, 0, 0, 0, 0. That's 8, 9, 10, 11, 12, 13, 14, 15, and that's what we got, 15. So it does require you to be able to break these things down. Now there's another one, let's scratch this out for a sec, called BXOR, be exclusively OR. This will return a 1 if only one of the inputs is a 1. It will not return a 1 if they both are. So here's the slight difference with that. One of them is, both of them are. One of them is, one of them is. So we get 8, 9, 10, 11, 12, 13. So if I BXOR those, I should get 13 out of the deal. And let's just make sure that's the case. 7 BXOR 10 is 13. It's probably a little bit rare that you're going to run into instances where you really need these bitwise operators, but gosh, it's good to know about them when they're there. So this is probably when I should point out where I found all this information. Help about operators lines all these up, and we'll get down to format, sub-expression. Oh, they're up here somewhere. Logical operators. Redirection operators, we'll get to those in just a second. Oh, here we are. Band, BOR, BXOR, BNOT, reverses. So you can read a little bit more about this if you want to, play with them a little bit. Again, if it's something you need, you super need it. If it's not something you need, you super don't care, but now you know they're there in case you do. We should also do a quick little refresher and extension of our Boolean operators. So if you remember, we had, let's see, is 5 greater than 1 and is 5 less than 10? Because both sub-expressions are true. And I didn't need to use parentheses around these, by the way. I just do it because it visually makes it a little clearer in my head. Because 5 is greater than 1 and 5 is less than 10, because both sub-comparisons are true, the overall result of this is true. If I did this where one of them is false, then the entire thing would be false. Or will return true if only one or the other or both are true. So if only one is true, I get that. If they're both true, I still get a true. XOR, exclusively OR, will return false if they're both true. It'll return false if they're both false. And it'll return true if one or the other is true. See, sometimes folks will remember these with something called a truth table. And the way you draw a truth table is you say, I'm going to do AND. I've got true and false in one input and true and false in the other input. And you just kind of draw this as a little table. The other one we've done is OR, true, false, true, false. And then we looked at XOR, true, false, true, false. So folks will draw out these little truth tables. And the way they work is this. An AND only returns true if both inputs are true. OR will return true if either or both inputs are true. So true and true, yes. True and false, yes. True and false, yes. XOR will do it if we're like that. So true and true, it returns false. True and false, it returns true. False and true, it returns true. False and false, it returns false. So that's one way folks will just kind of remember the logic on these things. And if that helps you to remember it too, then awesome. The last thing is not. Not simply reverses whatever the logic normally would have been. So if I was getting true, then I will get false. You'll notice that this is not a binary operator. In other words, not doesn't require an input on either side of the operator. There's also a shortcut version of this, like that, which will do the same thing. All it does is take everything after it and change it from true to false or from false to true. So some more Boolean operators for your amusement. Let's do a couple of redirection operators. Let's see, you're probably familiar with this one. Let's run dir and redirect it to dir.txt. This is exactly the same as using outFile dir.txt, only without file, you get to specify a bunch of parameters. Like you can specify append to have that added on to whatever was already in the file. And you can do something similar that'll also append. Sometimes you'll get an error message. Let's delete something that doesn't exist. We get an error. To bracket lets me output that error to a text file, just the error. So if we look at getContentError.txt, it's just the error text that got output to there. So a couple of redirection operators keep you amused in the evenings. Range operator is next. This is designed to take a value, 2 dots, and another value, and what it will do is create those 2 values and everything in between them. So it just puts those objects into the pipeline. Folks will use this when they're doing raffles at PowerShell user group meetings. You know, okay, we've got 50 people here, so we're going to take 1 through 49, and we're going to pipe it to get random, and person number 32 wins. And you can just keep doing that over and over until you've given away all your prizes. Sometimes folks will also use that to do a loop. So they'll say, look, I want to repeat something 100 times, so 1 to 100, and they'll feed it to a command called for each object. And they'll give it a set of curly brackets, and whatever goes in these curly brackets will now run 100 times. Dir is probably a boring thing to do. Let's stop that. Control-C. So the range operator, certainly useful. Few cases where it's useful. Definitely something you'll run across when you're repurposing other people's scripts. The format operator is next. Here's how this works. It starts with a string, and you use curly brackets to stick placeholders in here. And a placeholder, these all get numbered sequentially starting at 0. So that's why I started with 0 and the next one is 1. And you can also follow in with a comma and give it some formatting instructions like N2 for a number with 2 decimal places. You don't have to put them in order. But what they do is after you use the -F formatting operator, those numbers refer to the items in the list I'm about to create. So you have to give this an array. The first item, index 0, will be hello. That's a string. My second item I'll have be a fairly long number. My third item I will have be, I guess, another string. And so that's index 0. This is index 1. This is, oh, I was expecting index 2 to actually be a number, so let's put another number there. And then my fourth item, which is index number 3, will be a string. So what happened here? When I hit enter, it went in and grabbed these. So this is the 0 element, the 1, the 2, and the 3. They come in order that way. So this went there, that went there and got formatted as an N2. Number 3 went there. And number 2 went there and got formatted as an N4. And so this is a really useful way for just assembling some formatted output from time to time. You know, if you're doing hash tables and things like that where you need to put an expression and you want to have the result of that expression be a little formatted, the -F operator is a good way to do that. If you read the help file on it, it'll direct you to the MSDN.NET Framework documentation where you can find more about the different formatting strings that you can put in there. So it'll let you do date and time formatting, number formatting, all kinds of different stuff so that you can get things nice and pretty in your script output. Now this last operator I want to talk about is the dot sourcing operator, and I'm going to have to get a little bit ahead of myself on some things. First, I need to set my local execution policy so that it can run scripts. So I'm going to set it to remote signed. Remote script. Can't type and talk. Yep, I'm sure. Next, I actually need to create a small script. So to do that, for me, the easiest way is to get the ISE up and running. So I'm just going to do a very, very short script, function test. And we'll just have it output something small. And I'll save this in my C drive. We'll call it test script.ps1. Now we can close that. If I just run testscript.ps1, nothing happens. I defined the test function, but then as soon as my script ended, everything that my script defined went away. So it means if I just try to run the test function, it doesn't know it's there. So I'm going to run the script again and look at the slight difference I'm going to make. Here, // means the current folder. That first dot with a space after it means I want to dot source this script. That means I want you to run the script and let it define whatever it's going to define, functions, variables, and so on. When it's done, leave those things defined, meaning now at the shell level, I have a test function. Some folks will use this as a way to do an include. So let's pop open oops. I totally did not want to push that button. ISE. So at the top of their script, they'll dot source a couple of scripts. You know, the assumption being these scripts both have a bunch of functions that I like to use over and over. By dot sourcing them into this script will have access to those things. So in programmer ease, it's kind of an include. I don't want to tell you to make a heavy investment in this. I think there's better ways to do that. I think there's better ways for your script to refer to other scripts that it wants to use. That better way is called a script module, and we are going to work into that in the upcoming nuggets. But you're going to see people do this, and I want you to know what it is when you're looking at it. And if you're just doing something really, really kind of quick and dumb and dirty and ad hoc, isn't a bad thing to do. I don't like it in terms of its long-term supportability. It's not very structured. It's kind of a very quick and dirty ad hoc thing to do. So just be aware of that. Don't overly invest in it. Give me a chance to show you script modules before you get too excited about dot sourcing. Now that wasn't so bad, was it? We looked at the is and as operators for checking and manipulating the type of a piece of data. We looked at the contains and in operator. Remember, this is v3 and above only. Replace, split, and join. Some of those math plus assignment operators, plus, equals, times, equals, and so forth. You'll see those. Also looked at the unary operators, plus, plus, and so on. Bitwise operators, that was fun. Boolean, some redirection. Showed you, and really don't lose track of the difference between version 2 and version 3 on those. That's important. The dot sourcing technique, don't get too attached to that again. There's better ways to do this as we start moving into script modules and things like that, and some upcoming nuggets. It's a good technique. It's good to know what it is when somebody else does it in front of you, but it's not something I personally use a lot because I think there's better, more structural ways. The range operator, which can be fun, especially if you're doing raffles. The formatting operator, and the array operators. I hope this has been informative for you, and I'd like to thank you for viewing.